Okay, this time let's talk about this problem. It's called determine if a given integer is a power of 2. So basically the input will be an integer. The integer could be 16, integer could be 5, integer could be 4, the integer could be 0 or negative integer. So basically we can assume that we are going to get a Boolean if the given integer is a power of 2. So if this is a power of 2, for example, if it's 16, then we're going to return true. If it's 5, then it's not the power of 2, then we return false, and so on and so forth. We can fill in this form. So these two, we can assume that they are corner cases. So if the input is 0, we return false. If it's the number is a negative number, we will return false as well. So let's draw a conclusion here. So every single integer will have a binary representation. So for example, if it's 16, 16, it is a power of 2. So we can draw the binary representation like this. So we can have something like this. So every single integer is int 32. So at the 4th bit, counting from right to left, this is the least significant bit. And then this is the most significant bit. So we can find out that the 4th bit from the right side should be 1. So it's 2 to the power 4 equals 16. So based on this case, so we can have an algorithm. So firstly, we minus 1. So the integer will become 15. So this number is not very important for us. So if we minus 1, so 15, it will be, let's ignore the first part, it will be 0, 1, 1, 1 in this case. And then let's say this is x minus 1. So we are going to do a bit operation of n. So eventually, if every single bit we do an AND, it will turn into all 0 in this case. So let's try in the other case. If we have the number 5, so this is base 10 representation. So let's convert it to a base 2 representation. Number 5 in base 2, it should be 2 of 1. It should be 101, if I remember it correctly. So 2 plus 2. Sorry, it should be 0, 0, 1, 1. No, this is correct. So how can we verify this? So it's like a 2 to the power of 2 plus 2 to the power of 2. So it should be 4 plus 1 equals to 5. So based on our previous algorithm, we first minus 1 and then use an AND operator, bitwise operator. So let's see. If it's minus 1, it becomes 4. So it will become all 0 and will be 1. So once we apply the AND operation of these two numbers, we will get 0 all over here, but 1 and 1 should be 1. So this number is not equals to 0. So we can draw a conclusion that this should return false in this case. Okay, so let's move to coding. So a function signature will be like this. We're gonna return a Boolean value. Let's call it method name is power of 2. So our input should be an 32-bit integer. So let's capture our corner cases. If input is less than or equals to 0, we are going to return false. So if it's a positive integer, we are going to do this. We can just return the input -1, which is, and then apply the bitwise operation on top of it. According to the operator's precedence, let's check out the website. So we can assume that the AND operator has lower priority of the equality operator. So we may need to apply a bracket over here when we do this. So if it's equals to 0, then we will return true. If not, then we're going to return false. So let's try that in the IDE. Okay. Call this method. So our first test cases is 16. So let's see what we have here. So we are going to return true. So if we have 5, we return false. So our third case, number 4, we're going to return true. And also if we have -2 or even 0, we will capture it in our corner case. Okay, that's pretty much it. So another thing I want to check is the minus operator. Let's check its priority. Minus operator is here. So it has higher priority than AND operator. So I think we can remove this bracket. And then according to this theory, we will have the same result.